Hello, class. Welcome to week 5. We're now on of 6. So there is this week where we're going to talk about u-substitution, and next week where we're going to go back and review derivative stuff, and then we will be in good shape. So what is u-substitution? U-substitution is ultimately a way that we're going to do some antiderivatives. So let me start with just an example sort of question. So you might be faced with something like this. And remember what this is asking you for. This is asking you, basically, find some function f of x such that f prime of x equals x times cosine of x squared. That's what our indefinite integrals, or our antiderivatives, are asking for. So, like we've talked about before, you might start by trying to guess an antiderivative of x times cosine of x squared. So you might, for example, start by saying, well, let's guess, and this was really just a blind guess, but it might be reasonable to guess that, hey, maybe I want to integrate this x, which would give me x squared over 2, and integrate this cosine, which would give me a sine, something like this. Is it right? Well, we can figure that out because we can just take the derivative here. And if I take the derivative here, what am I going to find out? Well, I'm going to need to use the product rule. So I am going to get x times sine of x squared plus x squared over 2 times the cosine of x squared times, and don't forget we've got a chain rule here, so times 2x. And if you pay close attention to what just happened, you might actually notice that, well, this looks absolutely nothing like what we wanted. This does not look like that. But actually, if you look at just this piece, that actually looks an awful lot like the thing that we wanted. And how did we get that piece? Well, this piece is the derivative of sine of x squared. This was the second piece of the product rule. So this guess was wrong, but we can make another guess. Now we can guess f of x is equal to, and so let's take 1/2 of sine of x squared. Why 1/2? Because I saw here I ended up with this stray 2 that I want to get rid of. And so what happens here? Well, when I take the derivative, I'm going to need to use the chain rule, so I'll spell that out here. So my outside function here is 1/2 of sine of x. My inside function here is x squared. So f prime is 1/2 of cosine of x. My g prime is 2x. So little f prime of x here is, so it's f prime of g, so it is 1/2 of cosine of x squared times g prime of x, which is 2x. And if I move the x to the front and cancel the 2 and the 1/2, that will in fact be x times the cosine of x squared. That's the thing I wanted. And so our conclusion here is that the integral of x times the cosine of x squared dx is exactly 1/2 of sine of x squared plus c. Okay, that is the answer we're looking for. Now, you might be inclined, looking at this, to say, well, that's not very mathematical. You just guessed until you got it right. And I would have two comments to that. One is that mathematicians have to guess things all the time. But two is that this week our goal is to go over a method to make these sorts of guesses more systematic. In particular, the goal of u-substitution is to help us identify integrals that come from the chain rule in this way. So the integral that we started with, we didn't know it at the time, but this x here was coming from a chain rule that ultimately came out of the derivative of this x squared. So the goal of u-substitution is to undo the chain rule. Okay, so to start with, I'm going to redo the same question we just did, but I'm going to show you how you would do it with u-substitution. So I'm going to write this out, and then as I do it, I'm also going to write what the steps are. So times cosine of x squared dx. So the first step in u-substitution is always going to be to identify an inside function. Okay, and I mean that inside function in exactly the same way I meant it when we talked about the chain rule. So some function that's inside another function. And then I'm going to call it u. Okay, you can call it any name you want, but the reason it's called u-substitution is that for whatever reason, by tradition, we tend to use the letter u for it. Okay, so the only function here that's inside something else is this x squared. So I'm going to write here u equals x squared. Okay, then step 2, I am going to calculate du. Okay, and what is du? Du is the derivative of u. Okay, so the derivative of x squared is 2x. And I'm going to put a dx here. And just as a matter of how should you think of this, you should think of this pair of equalities as being your Rosetta Stone between two languages. One of those languages is the X language that your integral was originally given in, and another of them is this new language that involves the variable u. And so, roughly speaking, what's going to happen now is that we're going to translate this problem, which was written in X language, into U language. So we're going to use the fact that I can always replace an x squared with a u and always replace a 2x dx with a du to rewrite everything here in terms of u. So step 3. Rewrite in terms of u and du. Now I'm going to note when I say rewrite this, I have to rewrite all the x's. So make sure at this point that no x's or dx's remain. Okay. I'll go ahead and note here. If stuck, that is, if no matter how hard you try, you cannot get rid of all of the x's and dx's and replace them with u's, then you need to go back to step 1 and try again. Okay, so what does this look like here? Well, I'm trying to replace things using these two pieces of information. So first of all, I will notice that u and x squared, they are the same thing. So I am allowed to rewrite this cosine of x squared as a cosine of u. Now I have an x here, I have a dx here, and I notice that actually I can get rid of both of those if I have a 2 as well. So we don't have a 2, but we can make our own 2. So I'm going to here rewrite this to put the x next to the dx, because that's where I want it. So this is cosine of u times x times dx. And so I've just rewritten this, but again, I need a 2. So I am going to just put a 2 here, except if I do that, I've now changed the thing I'm integrating. So to stop from changing the thing I'm integrating, I'm going to put a 1/2 here up front. Okay. So what did I do here? I multiplied by 1/2 and by 2, which is the same as multiplying by 1, which is the same as doing nothing. So that's all that happened here. But now I did all of that so that I could say, hey, that's du. And so this is going to equal, and I'm going to put the 1/2 outside the front of the integral. Just like with derivatives, multiplying something by a constant just multiplies the integral by a constant. So I can write this as 1/2 times the integral of cosine of u du. Okay, and so this is what I meant by translating the integral. So this was our integral to start with, x times the cosine of x squared dx. And this is now the integral that we're left with, the integral of cosine of u du. And so the hope is that I successfully translated this integral, and that this integral is now an integral that I can do. Okay, so provided that all works out for you, you get to go to the next step, which I will call step 4. It's not a very creative name, I admit. Step 4 is just do the integral. So the integral of cosine of u, that would be sine of u. This is 1/2 times sine of u plus c. Okay, and now we're almost done. The only problem is we invented this u language. Up here in the blue box, we said we're just going to make this new language in terms of this new variable and reformat everything. So we can't give our answer in terms of this new language. So the last thing we have to do is translate back. So, namely, there's a u here, but what is u? U is x squared. And so that means that my real answer here is 1/2 times the sine of x squared plus c. So you'll notice, by the way, and that this should not be lost on you, that's the same answer we got when we did this with guess and check earlier, but this is more systematic. So really, at the end of the day, I said u-substitution is a method for integration, but really u-substitution is nothing more than a systematic way to do guess and check. It helped us sort of ferret out exactly where things were going, so I didn't have to guess quite so many things. Okay. But as we'll see in future videos, sometimes we're just going to guess wrong what thing to take as my u, and then we'll have to go through this process a few times before we get to the end. Okay, I'm going to call it there for this video, but in the next video, we're going to go over a bunch of examples of applying u-substitution. But until next time, be well.